Okay, I hope that for the end of this talk, this title can be clear to everyone in this room. Who I am? Well, I am a security researcher. I work in a Berlin startup now, Pitch, but previously I worked in Small PDF, that is a Swiss-based startup that process and offer an online, so in cloud editing tool for PDF that are still a thing after 30 years. So let's start from PDF in web application, because PDF has an interesting story. Created as a specification, proprietary specification by Adobe 30 years ago, so in 1993. And they released this format, portable documentary format, and a reader, Acrobat reader, now renamed in Adobe Reader, I guess, that allowed people to open and read the document, static document, or at least a sort of virtual version of a paper document on a computer. 6 years later, in 1999, Acrobat decided to have this smart idea to introduce JavaScript inside the PDF specification 1.3. Very smart idea, because this helped at least some of us to have a career and find a job in the future. But it is also interesting because JavaScript was developed and invented just 4 years before, so in 95. In just 4 years, Adobe was able to introduce in the specification an entire languages that can run in PDF file. In 2001, Foxy Reader version 1 was released, and it is still the major alternative in desktop environment for Adobe Reader. And in 2008, PDF became an open standard. So now there is an ISO, there is an association, there are companies that work to update the ISO. Now we have the PDF 2.0, released, I guess, 3 years ago right now. And it's no longer proprietary by Adobe. Of course, open PDF to the community, to the enterprise, to everyone, helped the company to create their own reader, to improve their own reader. And so in 2010, Google Chrome version 8 became the first browser to render PDF, to support natively PDF inside the browser. Before this, to open PDF, for example, from an attachment in the email, you need to download it and open in the desktop using a client. And now, we were moving to a different approach to PDF. So you can open them and visualize them directly in the browser. And so the browser became your PDF viewer, PDF client. Interesting is that the first version of PDFium, that is the core system that ran in Chrome to render PDF, was based on a Foxy technology that was a proprietary technology. In 2011, Mozilla released his own system to render PDF in browser, that is PDF.js, and there is a very important, a big difference between PDFium and previous PDF reader like Adobe or Foxy and PDF.js. Previous technology were written in C or C++. PDF.js is entirely written in JavaScript. So Firefox is able to render PDF file in a JavaScript-based reader. The project is open source and was designed and maintained by Mozilla. 1 year later, we have PDFtron web viewer that is released. PDFtron is one of the, now the name is a prize, but it is one of the other competitor in the PDF market. It is 25 years old, it's based in Canada, And it's famous because they acquired a lot of old but good and solid PDF technology. For example, the open source project iText. But because also they released this viewer that run in the client and allow you to open and edit PDF directly in the client. This means that you don't need to process the PDF in the backend, for example, but you can do a lot of manipulation, a lot of editing directly in the client, delegating the calculation cost to the customer or to the final user. And in 2014, Google released PDF as an open source project. So the first CVE of vulnerabilities that I want to present is 7 years old right now, and it is the first vulnerabilities found in PDF.js. So it was fun. The vulnerabilities was reported using Bugzilla, that is the Mozilla open source self-hosted platform to report bugs, not just vulnerabilities, but was reported by Vladimir Palant. I don't know if you already know this person, but he is the original author of AdBlock Plus. So it was quite good to write JavaScript code. He found cross-site scripting vulnerabilities. The first one, interesting note about these vulnerabilities. If you open PDF.js project in GitHub and you go on the security tab, you can find just one CVE founded in 2024. And this current vulnerabilities, that is 7 years old, is not in the GitHub security advisor database. The issues was a function, a PostScript calculator function that doesn't properly sanitize a user input, allowing, of course, JavaScript injection. Because this user input was an array, a numeric array, but the PDF.js code just checked if the input was an array, and that didn't check every item to be sure that was a number. We know that this exploit, or at least that some researcher or bug bounty hunter reported these vulnerabilities in at least 2 different bug bounty. Interesting is also that they reported in 2020, so 2 years later that the CVE was released and fixed by Mozilla, and showing also how can be not so easy to update an npm packages, especially if you don't expect a risk by the file, because a PDF open in the browser should not be so risky, at least for a company. The report were made to Slack and Nextcloud. So let's see the payload. This is the original payload provided by the author. And we can see that we have an object. So I don't know if you are familiar with PDF. You can open PDF like, well, normal people using Adobe or similar reader, or Vim, if you are crazy enough. And this is an object. And the object is a sort of container for instruction. And this instruction is just a function. And it works like a function. So there is a domain, and there is a range. That is, the domain is the input, and the range is the output. And this function just should help to define where a specific input should be put in the specific output. So the domain is the input, the range is the output. These are 2 array, 2 numeric array with just 2 items. But the researcher, the developer, have seen that injecting an item that is not just a number, the code was still processed by PDF.js. We can also see that the JavaScript injection, so the cross-site scripting vulnerability in PDF.js, is not related to the JavaScript, the embedded JavaScript feature that the PDF file can have. And this is interesting because often JavaScript in PDF is defined like a high-risk feature, and it is for a reason. But for a JavaScript-based PDF viewer, every input can be a risk, so you don't need to focus only on the JavaScript in the JavaScript. Oh, pointer. So let's see now another vulnerabilities, the CVE 2024. This is more popular. This is well known for two reasons. The first one is that it is more recent. The second reason is that it is in a popular package, still PDF.js, and it is in the security tab in GitHub of the project. And the blog post written by the author that found the vulnerability is a great blog post. So I really recommend it. Let's start with a quote from their blog post from Thomas Rinsma, that is the security engineer that found a cross-site scripting in PDF.js, so 7 years later after the first and unique cross-site scripting vulnerability in the library. You can be surprised to hear that this bug is not related to the PDF format JavaScript scripting functionality, because in our field, in the security, in previous readers, so client desktop-oriented reader, a lot of vulnerability were based on the JavaScript abuse, or for logical issue, so they implement methods that were unsafe by design, or for other kind of memory issue vulnerabilities, because the languages used to write to code Foxit and Adobe were memory unsafe. So this is the second CVE for PDF.js, 7 years later, still a cross-site scripting. Of course, if you have a client library, the cross-site scripting is one of the most critical vulnerabilities you can have. It is technically a remote code execution in the library context. In a very popular package right now, because in 2025, this package is downloaded by NPM 3.5 million. It has a 3.5 million download per week. So it is used in open source project, it is used in project, it is used in production, and it is used by Firefox to render PDF. So the surface is quite big. The issue, the font matrix array was not properly sanitized, allowing JavaScript injection using compiling glyph. What is interesting in this description is that the problem is still an array, a user input not properly sanitized, but it's still an array that is considered a trusted input just because, it is an error, it was a bug by the maintainer of PDF.js, but we can see that this CVE is quite similar to the previous one. Let's check the payload used. We have still an object. We have a font this time. When it's not fault of DNS, it's a font fault. And we have the font matrix. It is another an array of numbers. And still, the researcher tried to inject the code inside the array in the item. And we can also see that they break the code, the JavaScript code, to inject arbitrary JavaScript code. Let's see. The two vulnerabilities, so after 6-7 years, are pretty the same, and they abuse the same code. Yeah, maybe it is changed a little over the year, but it is the same function. So the author, the founder of vulnerability in 2024 understood that if they can inject arbitrary code here in the command, they can break the JavaScript code in the best scenario, they can inject arbitrary code in the worst scenario and run arbitrary JavaScript. So we can see that font.matrix has any check. It is considered just an array, and there is the dot slice to split the various items. And in this way, and then it is passed to the command, it is injected directly as JavaScript code. This is why here we have this. The parentheses and the comma help to break the JavaScript code to inject our line. And it is interesting to see that in 2018, the previous researcher, the previous person that reported the vulnerabilities wrote, it would send a malicious glyph to the viewer, and glyph that is being used to produce JavaScript code without order validation. And this is exactly what happened 7 years later. So what this researcher did is probably study the only previous vulnerability in PDF.js, understood how the PDF.js handle the JavaScript transformation and the JavaScript injection with a list of safe command, and try to inject arbitrary command exploiting exactly the same vulnerabilities. I recommend also the report written in Bugzilla. There is the link in the previous slide, written by the first researcher, because it helped you to really understand that this vulnerability was already technically found 7 years ago, but probably not totally understood by the maintainers, not because it is easy to understand the entire context of a so complex library. So what we have seen until now is PDF.js, that is definitely the most popular open source library to render PDF in client, so in the website front end. This library has only 2 CVEs. They are cross-site scripting. And the code was injected using similar methodology. And it's not based on JavaScript supported by PDF format. In addition, we need to know that PDF.js implemented JavaScript just 4 years ago, in 2021, if I remember correctly, and it is a very, very sandboxed JavaScript API, and a lot of functions defining the specification are not implemented because the Mozilla security team decided that it's not safe enough. But in what I want to present now, another vulnerabilities, now based on the Apprise editor. The Apprise is a company that provides proprietary technology and want to be a competitor of Adobe. The difference between PDF.js, for example, or PDF in Chrome, and Apprise product is that PDF.js want to offer just a solution to the user to visualize a render PDF in the browser. So you don't want to download Acrobat Reader, you want to visualize the PDF attached in the email without going out from the browser. And Mozilla offer this solution. Similar situation for Chrome. You have a PDF reader inside the browser, so you don't need to download or install third-party integration, because years ago, with the first version of Chrome, you need to install a plugin by Adobe. Now, Apprise want to offer a client solution for developers, so the target is different. It's not the final user. It's the developer that want to build a client-oriented solution to visualize, render, fill out, whatever PDF. And their goal is to be aligned to Adobe standard, Adobe specification. Why? Because in the enterprise, and especially in the public administration, a lot of PDFs, they have a lot of PDF. It is a mess. They can have a form, they can have a function, you can calculate the value in the form. And so they start to create this parity feature with Adobe editor in JavaScript. It is adopted by a lot of enterprise. It is used in Dropbox. It is used in Virtue, Small PDF, I Love PDF, Lumen PDF. So every PDF cloud-based company use Apprise, because if you can operate on the PDF in the client, you can save cost in your AWS, in your infrastructure or cloud infrastructure. So you delegate to the client operation that until 15 years ago you needed to do in the backend. It is popular enough to be a paid package in NPM, and this is a CVE, a cross-site scripting based on the JavaScript feature in PDF. So Apprise web viewer support some of the JavaScript function defined in the PDF specification, but to do this means that you need to find a solution or try to mitigate the risk of arbitrary injection. So they have a sandbox to restrict arbitrary code, but it is a sandbox in a JavaScript code base written in JavaScript. So let's see. This is the payload. So what we have here, we have an action, and the action is a JavaScript code. This is when you find an object in a PDF file that have /javascript/js, this means that there is an action in the JavaScript in the PDF file that run JavaScript code. And we can see console.println, a command inside, console.println and command inside, and until the last line where we have a windows.confirm document cookie. Okay, console.println is not a JavaScript web API. So if you turn to run it in your in your browser web development console, you receive an error. If you want to run console and print something, you need to use console.log. But console.println is the console log of Acrobat JavaScript API. So how this payload work? Well, come back. This payload work because we know that the sandbox written by Apprise is written in JavaScript. So our goal is to bypass a JavaScript code that try to sandbox our own JavaScript code. There is an old Medium blog post by a Rust security researcher that wrote these sentences. This is probably, if I remember correctly, the title of the Medium blog post. But building a sandbox in pure JavaScript is a full errand, and it is technically true. Google team tried for years to write sandbox in AngularJS, and they failed over and over in the attempt, because every time there was a security researcher that was able to bypass the JavaScript sandbox written by Google developer. In addition to write a sandbox in JavaScript, probably you will use an unsafe function to run the code that you want to run. So you will use eval after that you have parser the code to remove unsafe line. But you have an eval. That means that if the attacker is able to send the right string that you was not able to parse, the code can run. So how the Apprise code works? There is a parser, of course, because to render a PDF, every library, every editor, every client parse the PDF to render it correctly. And this is also why some PDF, the same PDF can appear differently in two different viewers, because the code base that visualizes the PDF, even if the PDF has a specification, can be implemented for various reasons in different way. And this means that you can have different renderization of the same file. It is very common in the printer, for example. So what we have here, we have a JavaScript code that parses the object in the PDF. So it parses also the embedded JavaScript code because Apprise supports it. So found the object with the JavaScript code, and then start to map every line, every Acrobat JavaScript API to a function or to a custom function or a function that is supported by JavaScript Web API. This means that console.clear is still console.clear, and println, even if it is obfuscated, is a very, very big JavaScript obfuscated. But this function just map println in console log, the classic console log. And this happens for all the Acrobat API, JavaScript API that you can have, or at least the supported. Then this output, after that they convert the JavaScript object to a JavaScript web code, it is passed to a JavaScript sandbox where they literally add a long list. I trunked this, but it is, the 80% of the sandbox is a list of variables that are defined as undefined. And why they do this? Because they want to be sure that even if you try to inject arbitrary code, you cannot run it, because they have previously undefined it. But there is a problem in this sandbox. After that, they have create this safe output. They pass to the eval command to run the JavaScript code. But it is very hard. I don't know if it is possible, honestly. If you have any good sample of JavaScript sandbox written in JavaScript that have no cross-site scripting or injection vulnerability, please send me, because I'm very curious. But it's very, very hard to write a JavaScript that cannot JavaScript sandbox that cannot be bypassed. And we can see what we have. You can now understand better the payload. Console.println is the Acrobat JavaScript function, but delete window is a function or properties that they didn't delete or remove in their sandbox. This allow me to delete the undefined value defined for window, for confirm, and for document. Deleting it, the three function, because they are JavaScript Web API function, window, confirm, document, come back to the original purpose, so I can use again, and then I can run this. The eval convert this in console.log. So if you open your web console when there is this malicious PDF in the Apprise web viewer, you can see that in console log you have a true, 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 and this means that we were able to run delete correctly, and then there is the pop-up. So we say that in the PDF.js, the previous two vulnerabilities were not based on Acrobat on the Acrobat JavaScript function, but PDF.js and also Chrome support a very restricted set of Acrobat JavaScript API. So why they are safe, or are they safe, or are they safe enough? This is the question. Well, yeah, they are safe enough. We cannot say that they are 100% safe, but they are safe enough because they adopted a solution to mitigate the risk that is quite different. The first one is that, for example, in PDF.js and PDFium, the set of Acrobat JavaScript function supported or API supported is very, very small set. And the second is that the security team in Mozilla in 2021 wrote a blog post where they explain how they implemented a sandbox to support a restricted set of API. And they, of course, evaluated JavaScript eval as a solution, but it was quite simple why they decided to not proceed in this way, because it is the best way to allow to run untrusted code. And so eval is unsafe by design, and it is. How PDF.js is able to run JavaScript, Acrobat JavaScript without exposing or without using a JavaScript sandbox? Well, they adopted two solutions. If you run PDF.js in Firefox, they use the same sandbox system that they have for extension. An extension in the browser should not be able to run arbitrary JavaScript code without the user consent. And the PDF.js supported natively by Mozilla use the same extension sandbox, and so it cannot access to the DOM. If you try to print using console println the origin, you cannot probably, but if you can, maybe editing the code and rebuilding Firefox, you can see that the origin of the page is not the URL, but it is the extension that runs in the sandbox. And for PDF.js that everyone uses as an NPM package, for example, so as client solution, well, they create a sandbox in WASM using QuickJS. So all the JavaScript code that you can run in PDF.js run in a WASM isolated sandbox. And yeah, you can try to hack QuickJS, for example, but it is interesting because QuickJS is not written in JavaScript, it's written in or C or C++. Sorry, I don't remember now. But this means that to find the vulnerability in the sandbox used by PDF.js to run arbitrary JavaScript code, you need to start to study probably C and C++ and find issue in unsafe memory languages. And so we are moving, we are increasing the difficulty, of course, and we are moving from JavaScript code base to C family code base, increasing definitely the complexity to find just an XSS. There is another library, a proprietary library, Nutrient, if I remember correctly the name, that use the WASM solution to isolate JavaScript. But instead of using QuickJS as sandbox, they use a different sandbox, duct tape. And it is interesting because you can find some open issue or old issue in duct tape where you were able to generate error in the sandbox, so in the duct tape code, not in the JavaScript code that can crash the Nutrient, but no injection. Last CVE that I want to present is another cross-site scripting vulnerabilities. This time is for a non-sanitized input injected directly in the DOM. It's not based on JavaScript object. It is based on annotation object. It is more similar to the PDF.js vulnerabilities, but it is interesting for two reasons. The first one is that I looked to find an alternative way to inject JavaScript code to bypass the content security policy in Dropbox. I was able to find a way to bypass the content security, but it was enough because Dropbox ran a private web viewer in a sandboxed domain. Good choice, Dropbox. Let's see the payload used. So it's quite basic. We have an annotation. This is the name of the file. This is the text in the form, and the reactor, it is define the dimension of the form. So if you open a PDF, you can find just a form that is pre-filled with this text. The original policy by Dropbox was this one, was a content security policy in a meta tag, and this give me and in the script SRC, you can see self and unsafe line. Why unsafe line? Because to run that specific version of Uprise, you need to have unsafe line. Fun fact, if you open the Uprise documentation, they recommend you to implement a content security policy. For the last version, you don't need to have an unsafe inline, but if you want to support JavaScript, Acrobat JavaScript API, you need to add to your content security policy, and it is written in their documentation, unsafe line and unsafe eval, that show you, just reading the content security policy, that Enterprise use an eval function to run the code in the JavaScript object. So a meta CSP has two, at least this one, have two benefits for an attacker. The first one is that there is unsafe inline, and this means that you can inject code if you find a vulnerability input, and this was the way how it worked. And the second one is that the CSP in a meta tag doesn't support report URI. So this means that the Dropbox security team didn't have visibility on my attempt. They cannot see that I was trying to bypass their security policy. And this is the main concern when you implement a content security meta tag. It's better to have in the header for this reason, because you can track the error. Now that we have seen 4 different CVE in 2 different packages, we can also see, and we have seen that 3 out of 4 were not based on JavaScript API, not based on app.alert. We can see that PDF are still complex for the developer, but also for the security researcher. And we have a lot of vulnerabilities in the meter database that are not real vulnerabilities. When you open a PDF file and you see an alert pop-up where there is written 1 or there is written XSS, it is a legitimate feature because PDF.js, PDFium support, but also Apprise support the JavaScript alert feature that is technically safe because it should not have access to the DOM. They cannot have access to cookies. But it is so common to write report, for example, for cross-site scripting vulnerabilities, where you just show a pop-up, that a lot of researchers didn't understand. A lot of researchers, a lot of developers don't know how PDF work, and so that alert have not a clear reason to exist, and so they consider these as vulnerabilities. But it's not. So this list is a list of CVE that I just stopped in 2020 because it was too long otherwise, and honestly I skipped a lot of them because there were too many. But this is a list of 10 CVE reported by our independent researcher like this in open source project. If you open the link, you can see that there is a discussion later, but still the CVE exists, is not removed. You can have a big company also that report vulnerabilities that are not vulnerabilities. This is just because JavaScript in PDF is supported, but it is sandboxed, so it's not the vulnerabilities. So some recommendation if you are a bug bounty hunter to prevent to submit this kind of report where technically you haven't found vulnerabilities. So the first one is understand the context. Where is the PDF rendered? In the website, so in the client, or in your browser? Because, for example, if you use an object tag, the PDF is not rendered by any library. It's rendered directly by the browser. And the PDF is rendered by the browser because Chrome, Firefox, but also Safari support the PDF visualization. This means that if you are able to use 2 different browsers, for example, I use Chrome and Firefox just as example, and the PDF viewer layout is different, probably you are not opening that PDF in the web application, but it's your browser that is opening that PDF. So the issue cannot be in the website. And the second is the payload that you use, app.alert 1 or app.alert XSS is not enough. Because, yeah, you can run an alert, a pop-up in your browser, but have you access to the DOM? Can you print a cookie, for example? If you cannot print a cookie, probably you don't have access to the local storage, to the cookie. You cannot run any privileged action. So how it can be a vulnerability if you can just print a 1? But there are also some recommendations for developer, maintainers, open source maintainers, for example, or bug bounty managers. So if you receive this kind of report, maybe it's better to ask for more details. For example, how you can have received a report of a cross-site scripting vulnerability in a PDF visualization if your code base has no library to render PDF. Where is the vulnerability in your code? Probably you are not vulnerable. And the second one is that you should not ask to the researcher to, if you read a bug bounty program description, often they ask for SQL injection, remote code execution, cross-site scripting. Yes, it's true. You want to describe which kind of vulnerabilities are important for you, and you want to describe the scope and the purpose. But maybe it's better to ask for a flag. Don't ask for an SQL injection. Ask to print the first line of the database. If they can print the first line of the database, the first row, probably they have found an SQL injection. Ask to print a cookie. If they can print a cookie, they have a cross-site scripting vulnerabilities. And in this way, you can avoid a lot of this shit where there are just garbage in a database that we cannot trust right now because a lot of people study previous vulnerabilities to understand what is a vulnerabilities. And they now think that a pop-up in PDF is a vulnerability, but it's not usually. Mitigation. How we can, if you are really use a PDF library to render your PDF in the web application that you wrote, how you can mitigate the risk? Well, you have some option, of course. The first one is a good content security policy. A modern content security policy based on strict dynamic plus hash probably can mitigate almost all the attempt. For sure, it could mitigate the two CVE in PDF.js and also one in Uprise. Isolated domain, if you work in a company that offers a service, has to isolate these packages. The PDF renderer can be in the subdomain, in iframe, something that helps you to isolate. Oh, it's over. And disable JavaScript code supported. Thanks. And if you have any question, I'm sorry for the time.